Hello. Today we're going to be taking a look at lesson 13-4. I know it seems kind of weird because we're kind of jumping around a lot, but we have been talking about similarity and things like that. So this one actually fits in very well with what we're talking about. 13-4 talks about congruent and similar solids. Okay, so we're going to be looking at scale factors and stuff like that, just like we have been with Chapter 7 and things like that. Okay, so we know what similar figures are. Let me just expand that to similar solids. Okay, so similar solids, again, same kind of idea. They're going to be the same shape. Okay, so we're going to be talking about, or comparing pyramids to pyramids, or cones to cones, or spheres to spheres. Okay, so they are going to be the same shape, but again, not necessarily the same size. Okay, and even though we're talking about solids, which are three-dimensional figures, we are still going to be looking at corresponding sides and things like that, just like before. And corresponding measures are in the same ratio, just like before, and that ratio we refer to as the scale factor, again, just like before. Okay, so we're really kind of doing the same thing. We're just now going to take a look at some three-dimensional figures and kind of what that looks like in a 3D sense. Okay, so for congruent solids, and to give us a visual, I'm actually going to just draw two prisms, which are going to look like boxes. Just to kind of go through some of these. Okay, and I don't think you're going to be asked to draw much today, so just do the best you can as far as your notes go. Okay, so for congruent solids, similar solids, whatever the shape may be. So I'm going to go similar as well. Okay. First of all, those corresponding angles are congruent, okay, just like before. So all of these angles in here, all of them are going to be congruent with, their corresponding ones. Okay. Corresponding edges are proportional. Okay, so the edges are going to be the segments. So like this is an edge, this is an edge. So like this one and this one correspond. So they're going to be in the same proportion as like this one and that one. So those are the segments. That's what the edges are. Okay. Corresponding faces are proportional. Okay, so the faces are like the flat panels. So like this front face versus this front face, okay? Or like this side face versus this side face, okay? Now with congruent solids, they're going to be the same size and the same shape, aren't they? Okay, so same size, same shape. So guess what their scale factor is going to be? We kind of talked about this before. Scale factor is 1 to 1, okay, because everything's going to be the same with congruent. Okay, so keep that in mind because you're going to be looking at some congruent things as well. Okay, so let me show you a few examples, and you'll see that these are going to be very much the same as some of the problems that we saw before. Okay. So here are the examples I'd like to go through with you, and the directions will say something like this. Determine if the solids are similar, congruent, or neither, then determine the scale factor. And of course, if they're neither, there is going to be no scale factor. So that would just apply to the ones that are going to be either similar or congruent. Okay, so here is the first one. I'm going to use pyramids for this. So again, just for purposes of your notes, just draw them the best that you can. Maybe you can kind of see how I'm drawing mine. This is 2 root 3. This is 2 root 5. And then I'm going to put a height in here. So this height in there is going to be root 7. I'm going to have another one. Remember, you can ask the substitute teacher to pause this at any time if you need to catch up on anything. I know I'm going kind of fast. Okay, you can hit the pause button anytime. Okay. So if we see things like this, we see square roots, we see there's a fraction in there, well, how are we supposed to determine? Obviously, these aren't going to be congruent because they're not the same size, right? Their measures are not the same. However, we can figure these out, like if I say, okay, well, 2 root 3 divided by 5 root 3, and then 2 root 5 divided by 5 root 5, and then root 7 divide by 5 root 7, 7 over 2. Okay, so you can plug those in your calculator. Divide by 5. So this one I got 1.2. And then again, 2 root 5 divide by 5. Oops. Oop, that should be a 5 root 5, shouldn't it? 5 root 5. And again, I got 1.2. And then root 7 divide by 5 root 7 over 2. That's not right. These should be 0.4. Sorry. I did 5 divided by 2, not 2 divided by 5. 0.4. Whoops. Okay. So this tells us that these are all the same, so these are going to be similar. And for your scale factor, I mean, you can just go 0.4 if you want. You don't have to put it back in a fraction. The fraction will be 2/5, okay? But, you know, you don't have to do that, okay? Let's try another one. Here we go. Let's do cones. Six and 15. And then 6 and 16. Okay. Now these are going to be pretty close, but you can probably tell just by looking at these measures. Like if you compare the 2 radii and then you compare the 2 heights. Okay, well this one is going to give us 1. If you divide this one out, this gives us like 0.9375, I think. So clearly these are neither. And then of course, because they're not similar or congruent, well, we don't really have a scale factor. Okay. How about this one? We'll look at 2 cones again. This is 15, and then this outside part is 25. I'll just draw in the height here. And then this one This whole thing is 30, and then this is 20. Okay, now this one's going to be a little bit more challenging because if you look at it, we have the outside part. Remember, this is called the slant height, and then we have the height here. Well, we can't compare those. Well, guess what? This is a right triangle, so we can figure out the height by using Pythagorean theorem. So let's see what we get. So I'm going to do that first so that I can compare height and height. Now on this one you could also do slant height on this one if you wanted to. It doesn't matter. Okay, so I'm going to go 15 squared plus h squared equals 25 squared. Okay, and 15 squared is 225. 25 squared is 625. So if I subtract, we get h squared equals 400. If you take the square root of 400, you get 20. So that means that this is 20. Now look, we can compare 20 to 20. 15, this whole thing is 30, right? Well, isn't that a diameter? So half of that is going to be 15. So each of these is 15. So look at that. 15 to 15 looks like these are congruent. Scale factor 1 to 1. Okay, so I did one of each just to kind of show you what you're doing. So I mean, the same ideas apply. All right, I want to do one final example, and then you'll have some time to work on your assignment. So in this one, let's say a sculptor has been asked to make a statue in the shape of a rectangular prism. Remember, that's like a box. Okay, kind of like the first one that I drew on the previous page. If the model, so like the smaller version, the model is 10 inches high, 12 inches wide, and 15 inches long, and the scale is 1 inch to 13 inches. What are the dimensions of the statue? Okay. So we have our scale, and then we have our first dimensions. Okay. So if 1 inch is going to equal 13 inches in the statue, in this case, if we want to blow it up, we're going to multiply each of these by 13 over 1, right? So this one we would get 130 inches high. 12 times 13 over 1. Okay, so 12 times 13, or 13 over 1, is going to be 156 inches wide. And then finally 15 times 13 over 1, that is going to be 195 inches long. Okay, so those are going to be the new dimensions of the statue. Okay, and that's all I have for you. Your assignment is on the sideboard as usual, and I will see you guys on Monday. Have a great weekend.